So this is Jam 2024, problem number 22, as you can see on the screen.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning.
Question has asked that there's a random variable x. I hope all of you know about the definition of a random variable, which is the exponential 1, 5 distribution. I hope all of you know what is exponential 1, 5 distribution. Of course, this means for any x greater than 0 because exponential distribution has support. You know what is a support, right? Like the set of values for which the probability of or other the PMF or the PDF for the continuous distribution in this case is greater than 0. That is called the support. So that means it's only defined for x greater than 0. X, the random variable x, is nothing but a function from the sample space to a real number line, right? So it means that x greater than 0 means it's only taking values in real plus, and it's a one onto function. So it's saying what is the conditional distribution of random variable y given random variable x. So I hope you all of you know about this concept of a conditional random variable, and it's given that this is normal x comma 2. Then you have to find out the variance of x plus y. So this is the whole idea. So let's revise what are the concepts involved in here. Rather, what are the pieces of information given? So you're given x, you're given y is equal to x information, right? And you know this follows exponential 1 comma 5, 1 by 5. I'm sorry, I guess x greater than 0. And let me like make it blue. And here it's given that it's normal x comma 2. So this is the two informations given. Now your goal is to find variance of x plus y. So essentially it's asking you that you have x, you have y given x is equal to x. Can you use this to find x plus y? So you're given information about x, you're given information about y given x. Can you use this to find information about x plus y? Some information. This is the question mainly. All of you understood this, the components of the question. Now, once you have the component of the question, you will be able to, once you understand the components, you will be able to accumulate them to understand, right? So it's the assumption is that that you know what is what is the meaning of each of this component. Okay, that is the assumption from my end. Okay, so how to approach this problem? You can easily understand that from x and from y, given x is equal to y, you can easily find what? You can easily find y, right? You can easily find y. How? Because you know that f of y, the PDF of y given x is equal to x of y given x is nothing but this is the y times f of x is nothing but f of x comma y of x comma y. You know this, right? So you know that let's write this. So you know that from this too you can easily find out the joint distribution. So yes, so now can you go back to this x plus y? Yes, of course you can. You know how to find the conditional distribution, right? Like you know from this x y you know how to find f of z is equal to x plus y. That is one way out, right? But let's try out in a different way. Can we do it without doing this? That's the basic question. So we will do this method from scratch, but let's try out a different method, or let's try out a different method, or let's try out what we can do to minimize the process. So understand, you have this information, you have this information. So whenever you have this information, the basic idea is to always condition. So there is a basic result that if a variance of z is nothing but expectations of variance of z given x plus variance of expectation of z given x. This is called smoothing property, okay, of a random variable. So now let's see what is z here. We assume z is equal to x plus y. So let's put that. So let's assume z is equal to x plus y. If you put it here, you will get variance of x plus y is equal to expectation of variance of x plus y given x plus variance of expectation of x plus y given x. So you know given x is a constant, so you take it out. So you get x, variance doesn't matter. So it turns out variance of y given x because x is a constant. Remember that. Plus variance of expectation. Now x is a constant, so x comes out plus expectation of y given x. Now let's calculate that. So now you know what is y given x is equal to x. So now you can know the variance of. So what is the definition here from here? There are two definitions. Expectation of y given x is nothing but just find the expectation here in this case, which is x, right? And so the expression of y given x will be capital X. It's a function of x. And variance of y given x will be nothing but 2 because it's 2. You know that. You can easily understand that. So therefore you just replace it here, variance of expectation of 2 plus variance of x plus expectation of its x. So therefore 2x. So therefore you get 2 plus 4 of variance of x, and variance of x, so you get 102. That's great. So which is there as an option. So the question is not just to solve this problem in this way. The question is that do you know the meaning of this very clearly? What this really means. This is the most important part. This is a problem solving strategy. But what does this mean? How does this come from? Also, is there any other way out? Because you want to go to the very crux of the problem, right? Now, why did we use this method? It's because this method tells you that this method is the beauty of this method is the following. In this case, what you would have done is that would have found out their distributions and then found out the distribution of x plus y and then found out variance of x plus y and expectation and variance. That is one way out. But what if, I mean, is there any other way out? And that's why this comes up, and this is the whole idea of the law of the unconscious statistician, which says that if you so let me tell you the law of the unconscious statistician. What it says is that, let's say you have random variable x with f some distribution. Now you make another random variable g of x, let's call it y. Now you want to find expectation of g of x. Now this expectation of g of x is nothing but you have to first find the distribution of y, right? Then you can find it. So let's say you find out the distribution of y and you say, okay, this is y. So what we do is that integration whatever minus infinity to infinity y of fy dy. But what the law of unconscious statistician says is this simple that, okay, so expectation of x is what? Expectation of x is nothing but integration minus infinity to infinity for a continuous 1x f of x dx. So what will be the expectation of g of x? We said that it will be like this, but what the law says is that if you unconsciously replace this as g of x, then also it's true. Let's say you say, oh, instead of gx, I replace g of x, then also it's true. That's the best part. So this is what the law of unconscious statistician is. So what it means is that we do not need to find, we can use this the distribution of x to find out the expectation of a different random variable. So what it means is that for finding out variance, this should be the intuition of yours. For finding the variance of any other new random variable, there may be a way out without finding its distribution, without finding the distribution of x plus y. There may be a way out because of the existence of the law of unconscious statistician. There may be a way out, and that's where you should strive to find that, right? There may be and that's where this idea should come to your mind, that the variance of a certain random variable does it have any relationship with the conditional stuff. And so therefore the next natural question is that we want to find the variance and we have the conditional information. So is there any relationship between that? By conditioning on x, can I find that? And that's where that leads to this question, this idea, and then we apply it.
To book a trial class for your preparation courses of IIT MS, ISIM STAT and CMIMS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.